In this fourth part of our application, inside the same function, we are going to extract the values necessary to populate the other three tables in the MySQL database. These would be the values for the CPU utilization, processor and I/O memory utilization, and the number of interfaces that are up on each router. Using these values, we are going to calculate some network averages and top 3 resource consumers in the network. Now remember that we already defined a list and a dictionary for each of these 4 MySQL tables right here before the function, these ones. For example, in the CPU values list, we are going to store the CPU utilization values extracted from each router and then determine the network average. The information we're going to store in the top 3 CPU dictionary will help us determine the top 3 most CPU intensive devices in the GNS3 network. Now let's go to a router console and see the output of the commands that the program sends and which are related to the CPU utilization. I'll take the command from here, so let me find it. Okay, show processes CPU. Okay, let's go to R1. From this output, we are interested in the value for the last 5 minutes. So, this one over here. I think it is the most relevant for network monitoring purposes. To extract this value, let's get back to the code. I used the search method right here and regular expression syntax, and then using the group method, I pointed right at the value we need and stored it in the CPU util per 5 minutes variable. Next, because we are running this function for every device in the network, I'm gonna append this value to the CPU values list that we created earlier. Of course, converted to an integer because we want to calculate the numerical average. So that's why I use the int function right here. Next, we should also populate the top 3 CPU dictionary. Inside this dictionary, we'll have key value pairs, where each key is the host name we extracted earlier, and the associated value is the actual CPU utilization value for that host. This is also a good reminder of how to insert data into a dictionary. Okay, that's it with the CPU utilization for now. Next, let's see how to do the same thing for the processor memory and I/O memory values. Since the steps for extracting each of them are identical, I'm going to discuss only one of them. So, first let's see the command in the CLI of R1. So we have show memory statistics. Since we are interested in the processor memory, we are going to refer to this row over here. So, the first row. Using regular expression syntax, let's see the code, and then the group method, group of 1, I decided to extract all the information in that row following the word processor. So notice the regular expression right here. Next, using the split method and 3 consecutive spaces as a delimiter, because this is how we have the values separated in the CLI output. 3 spaces, 1, 2, and 3. Okay. I have extracted the values of the total processor memory right here, and then used processor memory. Let's see them in the CLI. So this is the total processor memory and this is the used processor memory. Considering these two values, it's time to calculate what is the percent of used processor memory from the total processor memory. This will be a floating point number, so we should use the float function in the formula. So this is the formula right here. This is the float function applied to the total processor memory value. Also, using the format function, we can specify how many digits we want to see after the decimal point for this formula. So we pass the entire formula as the first argument in the format function. So notice this first argument. And then .2f, which is the way to refer to the number of digits after the decimal point, as the second argument. After doing the math, we are storing the result into a variable, procmem%, and then append that variable to the procmem values list over here. As for the top 3 processor memory dictionary, we add a key value pair each time the function is executed on a router, consisting of the host name as the key, right here, and the processor memory percent as the value. This will help us determine the top 3 processor memory consumers in the network. Next, I did the same thing for the I/O memory and the number of up Ethernet interfaces. This is the code right here, so I won't repeat myself explaining their code. The only difference is that for the interfaces, you should look at the show IP interface brief command output and pay attention to the pattern matching. Notice that first I use the find all method to have a list of all the Ethernet interfaces returned, either simply Ethernet or fast Ethernet or gigabit Ethernet. That's why I matched 0 or more repetitions of any letter before Ethernet, so this regular expression right here. Next, I use the find all method again to get a list of Ethernet interfaces that are up and up. So notice the regular expression right here, meaning status is up and protocol is also up. Now to apply the formula and get the percent I need, I use the len function on both lists to determine the number of interfaces in both cases. So you can see the formula right here. After filling all the lists and dictionaries we defined, we should send the values we extracted in part 3 of the application to the MySQL database into the network devices table. Inside the same function, we call the SQL connection function, you can see it right here, because we want to send the parameters we extracted from each router to the database. So each time an SSH connection is established and the values we want are pulled out, we want to also populate the MySQL tables. Let's get back up to the SQL connection function. Remember that the function takes two arguments when called, the command and the values for that command. Then it executes that command using the cursor object right here. Now let's go back to the bottom of our SSH function and let me describe this SQL command that we're executing in our database. Okay, there it is. Remember from the Python and MySQL section that we used the insert into SQL command to add entries in a table from the database. Go back and revisit that section for a quick SQL review. This time, when inserting an entry in the network devices table, we will use the replace into SQL command. Replace into works exactly like insert into, except that if an old row in the table has the same value as a new row for the primary key, the old row is deleted before the new row is inserted. If we go in the MySQL console and issue the describe command for our table, so let's see it, we can see that the MAC address has the role of primary key. This is it. In a MySQL table, the primary key must always be unique and not null. I chose the MAC address as the primary key for this table because its value is unique for each device, so I thought it would be the best choice. Now back to our replace command in the code. This command will add a new row in the table only if the MAC address value of that row does not already exist in the table. So as long as we keep the same routers in this network and we keep running the program periodically, we will not see R1 multiple times in the network devices table. Instead, every time we run the application, it will extract the MAC address of R1. Then it will check if it is in the SQL table. If it's already there, then it will not add another entry for R1. It will just delete the old one and replace it with the new one. This way we can have an updated value for the uptime each time the program is executed. Of course, if we add a new router in the network, it will be added to the SQL table as soon as we run the application again, because it will come with a new MAC address. I hope this is clear. Except the replace keyword, the rest of the syntax is identical to the one used for insert. The first argument passed to the SQL connection function is the SQL command itself, so replace into the name of the table and then the columns. The second argument is a sequence of values. Let's see it. So this one over here. Values that are associated with all the %s format operators in the command. So all the % operators right here. When the command is sent and applied in the database using the SQL cursor object, the values in the second argument, so hostname, MAC, vendor, and so on, are mapped to the format operators and the command is sent as a whole. Next, we close the SSH session and create some error messages in case the SSH authentication exception is raised, using of course an except block. Also, we should set the check flag to false for further verifications. Finally, we define and use the create threads function as we did until now. So this is the function right here. Next, let's have a look at the final part of this application.